Let's talk about a pump. The components that make up a pump. We're going to talk about a submersible pump because that's what everybody sees most of the time, and pretty much this is going to cover anything that we see in a pump. You got your lifted arm, your cord cap. Pump, real quick, just to say this, a pump is a motor with an impeller mounted on the end of it. That's all it is. It's just a motor with an impeller. And then we've got these components that make it up. You've got a cord cap that comes in. This is our first submersible pump. This is what most of you see at your lift stations. And you've got submersibles. Anyways, you see you got your rotor and your stator there, bearings, pretty much same. We're going to get down here and talk about the seal cavity, your oil chamber. Everybody knows what that is. Everybody know what the oil chamber is on a submersible pump. You've got your mechanical seals. You've got to do something to keep the water from getting into this housing, because as we all know, water and electricity does not go together. Real quick, I will say this. I had a customer this last week sent in I believe a 20 horsepower pump. They said, we want to do insurance claim on this, lightning fitted. I said, okay. So I get it in. The motor's not even shorted. And it's plumb full of water.
No,
I said, how can I do lightning claim when there's not even a short? Now I probably faulted out because there was moisture.
Seal problem.
Ran, but they wanted to do a lightning claims. But we'll get that sometimes. Anyway, so you got an impeller down here. You all will see these discharge brackets, your discharge elbows, your lift and rail, all your rail package. I don't see a lot of that stuff. My guys in the shop, when they're working on this equipment, they don't see a lot of this. They don't know what goes on. And they're just like you all. I'm a little bit lucky. I get to go out in the field and see a lot of stuff. They're like you. They get to see from here over. They don't get to see any of this stuff. You know, what all the system does. They understand it to an extent. But to understand the system, you have to see everything. So they get this pump in, and they get all of this in. Well, what's this go to here? Well, it slides down a rail, clips on a bracket, and pumps the water in. So, now, what's going to happen when this right here fails? Is that part of the pump, or is that part of your all system? That should be, you know, if it's on the pump, then we usually try to take care of it. But we have to try to put O-rings on or do something like that. I'll tell them myself. Right, Rick? Anyways, anybody got any questions about the components of a pump? The question on what kind of test?
Certification exam.
Certification exam. Positive displacement or centrifugal, correct? What is the difference?
Yep. Well, on the certification exam is you actually have to pick out examples of one or the other.
Okay.
And it might ask you which one is not.
Okay. This is hard to see. Back on page 8 in your book, I will tell you this. This is hard to see. I'm sorry for the bad pictures. Pretty short.
They had to get scanned in, and we did the best we could, but tweaking them, but it, you know, it just
I procrastinated a little. Waited till the last minute.
And then I didn't print them till the last minute, so.
A centrifugal pump, real quick, I'll explain the difference between a centrifugal and a positive displacement. Or does anybody else want to explain it? All right, a centrifugal pump works that it can only pump what it can get rid of. So does that make sense? So if it can't get water, it's not gonna pump water. If it can't get rid of water, it's not gonna pull any water in. Does that make sense? That's called centrifugal pump. It's just gonna sit there and turn it itself. If you close the valve off on a centrifugal pump, we call it deadheading. You can close the valve off and it's not gonna do nothing. Now it's gonna build pressure because it's gonna try to do something, but it's not gonna blow something up. Now if you've got a bad spot or something in the system that you don't trust, and some kind of little cheap pipe or something, you can blow a pipe. But theoretically speaking, a centrifugal pump is not going to build so much pressure that it's going to destroy itself. A positive displacement pump, on the other hand, is whatever it takes in, it's going to get rid of. And it's going to keep compressing it until it gets rid of it. So you'll see these a lot in high head applications. Positive displacement pumps, the pit pumps, the gear pumps, the rotary load, the pistons, diaphragms. That means when they get a product in, it's got to go somewhere. And it's going to keep pushing it. And if you close that valve off, you're going to blow something up. So remember that. If you've got a positive displacement pump, do not close them off. Expect nothing on it.
Better have a safety switch or a pressure switch if you do.
That's right.
We've got the rotary screw press or progressive cavity with the rotor and the stator.
Right.
And we have pressure switches on the other side, and we have had instances where we pumped against a closed valve, and once it reaches 25 psi, shut it down. It's good to have that in play somewhere, because everybody messes up every now and then.
And that's back to safety. We don't want to blow something up and hurt somebody. The types of centrifugal pumps, inlines, close coupled, submersibles, verticals, all of these types of pumps that you see on page 8, that's just types of centrifugal pumps. That means that if you drop a submersible pump in a pit, like your sewer pumps, drop that thing down in a pit and you close the valve off, it's not going to pump nothing. It's just going to sit there and spin in itself. Now, if you've got a closed coupled pump, you're a little bit lucky on a submersible with submerged water. But you take a closed coupled pump or this kind of pump, a split case pump where you're setting out, you don't have cooling, and you close the valves off and you're letting that pump spinning itself, that liquid will heat up quickly and burn your seals out. Now, when I say quickly, I don't mean 30 seconds. But, if you close your valve off, if you've got a valve that's an automatic valve and it fails, and you can't get water away, you can burn the seal up. I've got a customer over here in Glasgow that has problems with the seal. They was going through seals on this particular pump. It's a 20 horsepower pump, just a closed coupled pump, which is right there. They was going through these seals. We was replacing seals every 2 weeks to a month in this pump. And they was trying to figure out what would happen. We was telling them something's going on. So we kept changing seal types. We put about every kind of seal with a magnet they make in this pump. We went from $40 seals to $600 seals. And finally I got one that failed, that I found out the problem. The faces was welded together. I used a tungsten carbide seal and the faces were welded together. So then I go back to the customer and I say, hey, what are you doing to this pump? Well, we're not doing anything. Well, come to find out, the operator was going to break and he was shutting the valve off. He would be gone for 15 or 20 minutes, burning the seal out. It didn't just do it the first time, but after so much time, the seal failed. They rewrote the program for the PLC. Then all the PLC stuff's over my head. Anyway, they rewrote the program to where it done something, it shut the pump off. Anyways, problem's done. So, to The problem was, is the water was sitting there dead-hitting the pump and we burned the seal out.
Also, on that type of talking about also too, cavitation is just the opposite side of that. Not water, will, like the cavitation valve, air pockets and so
Right.
on will cause the same type of issue on it. Similar.
The only problem with seals, if you don't have enough coolant, they'll run real good as long as they stay cool. And if there's some water in there, they most of the time not going to give much problem, as long as they can stay cool. Because those spaces, and I've got some examples up here we'll show everyone, if everyone's not familiar with mechanical seals and how they work and packing. But cavitation usually cures when, and we'll get into that more in pump troubleshooting, but it's, you know, it's air pockets in the water, you can't get enough, it's suction pressure, discharge pressure's out of balance. And usually that won't cause seal problems, that usually causes other problems in the impeller that will later cause the seal balance problems.
Right. Well, I worked with Tulsa for a while and we had some pumps, it was hydraulic.
Yes.
Wise, pumping hydraulic full
Yes.
versus water. And we had to be careful with cavitation sometimes. One of the things, of course, you usually hear it anyway.
Yeah.
Rattle, rock and roll in, so. But I was just curious if that would be the same thing, kind of burn the seals out, which I always heard it would, but it's the other problems that cause the seals.
Right.
So,
Usually cavitation is going to affect whatever the product that these air is hitting. It's not really going to affect the seal because the seal's not hitting this. But what happens is you get an impeller that wears, you get wear on an impeller, you get out of balance, you get vibration, the seal wears out. Or less water. If you ain't got enough water, your seal's going to overheat. Heat kills seals.
Float switch bracket falls into the wet well. Yeah, that had to do. I've seen that.
Any more questions on the types of pumps? Anybody got any questions? I'm sure y'all got some types of pumps that you got a question about. Somebody does anyways. I've seen all types of pumps. We've worked on about, and we still see new stuff sometimes. I see, yeah, they would have made something else, but you know, we've worked on, you see so much out here. This utility's got this engineering firm, this utility's got this engineering firm, this guy likes this type of pump, this engineer likes this type of pump, and so you see everything.